Hello and howdy, ladies and gentlemen. Root Beer here, looking at question number 22, our second question in Part C. And this is on the 2009 Cayley contest, grade 10 contest there. And what have we got? Question 22. Suppose that A, B, and C are three numbers. They're not saying integers or anything like that. But we've got A plus B is 3, AC plus B is 18, and BC plus A is 6, and we just want the value of C. Okay, so when I see that, sort of some of my math experience kicks in, and I see, okay, I've got three unknown values, A, B, and C, and I've got three equations. In theory, I should be able to solve all three. Of course, if I just need to get C, maybe there's a clever way to do it. Okay, so, one thing you could do is say, okay, I've got that first equation, A plus B is 3. I can change it to A is 3 minus B, and now everywhere I see an A in the other two equations, I can put a 3 minus B in there. Then I'll have just two equations with B and C's in them, rearrange one to solve for C, and then plug that back in to the last equation, and it should all work out. Okay, that would be perfectly fine, and we'd probably be able to knock off A, B, and C pretty quickly. But if we just need C, let's see if there's a clever way to do it. Okay. So I notice only two of the, what I'm going to do? I'm going to copy this to a notepad here. But I notice only two of the equations have C in them. And the first equation here was 18, I'm pretty sure it was 6. Yeah, 18 and 6. So the first equation tells me something about A's and B's. Okay, I don't know what A is, I don't know what B is, but together they make 3. And I notice here we've got some multiples of 3. So, I also notice that 18 is 6 times 3. So I might instinctively say, well, could I multiply equation 1 by equation 3? And that should be equal to 18, which should be equation 2. But if I do that, and if you need to, write it out to make sure. But if I do that, I'm going to get some squares in A. So I'll have an A squared, I'll have a B squared, and I feel like it would just be making things a bit messier. Okay, but C only appears in 2 and 3. And there's an AC and a BC, and then an A and a B left over by themselves. And one of the reasons we wouldn't want to have any A squareds or B squareds lying around is because then we'd start getting quadratic terms, and we'd start, getting possibilities. Could A be of the positive root or the negative root of whatever we've got? But if we keep everything linear, we might have a shot here. So I think if we add up 2 and 3, on the right-hand side, we're going to get 18 plus 6 is 24. And then we'll get A plus B times C when we add these ones up, and then an A plus B. So here I've got 3C plus 3 is 24. Subtract 3 from both sides, 21. C is going to be 7, and I still have no idea what A and B are. It doesn't matter. All they wanted was what is C. So there we go. We got a very quick way of getting C. No mess whatsoever. Now, so there we go. C, the answer is E. However, just, in case you're one of those people who wanted to try it another way, or aren't one who sort of believes that there's usually a quick, clever, slick way to do it, if this were question, say, 14, then I'd say, probably there might be a fast way, but is it really going to be faster to, add two equations and then divide or something? Or should we just try and find A, B, and C? But since this is a Part C question, I usually think, well, there's probably a fast way to do it. But maybe you didn't see it. Let's see if we can get A and B just for fun. Okay, if you're not interested, move on. Next video will be question number 23, of course. But let's see if we can get A and B as well. Maybe double check our work, just in case you're one of the people who did solve for A and B. So let's get ourselves another page, fresh sheet, and we'll write down the equations again. And I think I'll go with my sort of initial suggestion, which was, well, let's rearrange equation number 1 and say that B is 3 minus A. Okay, So we'll put that into both of the other equations. And so anywhere I see a b, I'll put 3 minus a. So we'll get 3 minus a over here. Okay, what can we do for that first one? We can do AC minus A and subtract 3 on both sides, so that'll be 15. And then down here we'll get 3C minus AC plus A is 6. Now, right there, we'll use purple to highlight. This part here is sort of staring me in the face. The AC and the minus AC should cancel out. The minus A and the A should cancel out. And when I add these, I'll once again get 3C is 21. Okay. There doesn't seem to be a good way to, well, I suppose we can get A in terms of C. Just really quickly, I'll rewrite these equations. So AC minus A is 15. And then we've got 3C minus AC plus A is 6. So I'm going to take that first equation, I'm going to factor out an A. A times C minus 1 is 15. And so I can get A in terms of C. Okay. Then I suppose we could take that and plug this into our final equation. So I'm actually, how do we want to play this? I guess 3C minus 15 over C minus 1C plus 15 over C minus 1. And that's equal to 6. So we're going to get C again in a moment, but this is, certainly taking a little while. Okay. So you can definitely see the advantage of my earlier technique, or maybe I just didn't set it up the right way and I'm taking too long or something like that. But I'm going to multiply by C minus 1 everywhere, so I'll get 3C, C minus 1, minus 15C plus 15 is equal to 6C minus 1. See, here we're starting to get that pesky quadratic. I think we'll get an answer of C could be equal to 1 or 7 here, but let's not count our chickens before they've hatched. We get 6C minus 6. We've got some cleanup here, so minus 3C minus 15C and bring the 6C over to the other side. So we'll have minus 24C, 3C squared, and 15 plus a 6 is 21. Divide by 3 on both sides. And we can factor this. C minus 1, C minus 7. C is equal to 1, except remember A is 15 over C minus 1, so that's not going to work. Or C is 7. Yeah, we already knew that, but we're going the slow way around here, just in case. So A is 15 over C minus 1, so that's 15 over 7 minus 1, that's 15 over 6. Divide by 3 on top and bottom. A is 5 halves. And then what was B? B is 3 minus A, so that's 3 minus 5 halves. Or 6 halves minus 5 halves. B is 1 half. Okay. So now we have all the numbers, and if you want to, you can double check that they do all work. Okay. For example, AC is going to be 35 over 2, and then we add on a half, that'll be 36 over 2. That is 18. Okay. So we've got all the numbers, but I would draw your attention to the fact that we didn't need all the numbers, and it took me 2 pages to figure out what C was, and then from there I very quickly got A and B. Okay. So, either doing the very first method I did, or, if I go back here just for a second, at this stage, when I circled or boxed things in purple, when it was just sort of screaming at me, add these, add these, add these, that would have been fine too. And either way, we would have gotten C fairly quickly. No quadratics, no problems like that. Okay? But we got our answers, and that's okay. So up next will be question number 23, the midway point of the Part C questions. Give it a try if you haven't already, and I will see you for that in the next video.